Today we are going to discuss about basically Okay, so hi everyone. I think I'm audible and visible to all of you. Hi, Durgesh, MCK, Amarnath, Amrendra, everyone. So I believe I'm audible, right, guys? Everyone. Okay, Mali, good morning. Yeah, okay, fine, that's great. So yesterday's video I have not uploaded, so there was some issue with the yesterday's video, but yeah, so like we found out the issue. Basically, like that video got extended. I have not switched off the recording for the like yesterday's video, so that video became very long. We just have to like cut that video and then upload it. So I think in some time, so video will be uploaded. So you will not be able to find out yesterday's video upload. I mean, like you will be able to find out the live classes, but yeah, not in a player format. So we are going to upload it. So just an update for all of you guys. Okay, fine. That's great. So let's get started. So yesterday, I believe I was talking about GRU first, which was a small model, and then we were talking about basically transformer architecture, which is a mother of everything that you are able to see in a space of like LLMs or especially NLP, if I'll say. Right. So now this LSTM or like GRU, whatever we have discussed, so it's become obsolete because no one is going to use it for any kind of a job or any kind of a task that we used to solve before this era of AI, right? So but yeah, so like if you're trying to learn those things, so obviously you have to go in a step-by-step manner, like I have mentioned yesterday. And obviously you should know about the LSTM, you should know about the GRU, because this is something which is going to build your base, right? So if someone will come and then out of nowhere start discussing about the transformer, maybe you will not be able to understand. And this is where this fundamentals, this like a base concept, it's already uploaded, GRU and transformer. No, Teddy, it's not uploaded actually. It's a part of live class itself. You will not be able to see the control. It's not uploaded. We know that. So yeah. Okay. So fine, because in an uploaded video you will be able to see all the video control, and in non-uploaded video, live class video, so means videos are there. I'm not saying that video is not there, but yeah, it's not the recorded one. It's a live class video, yes. Okay. So now in today's class, I'll try to talk about a couple of things. Let me share my screen and then let's start talking about these things. So today, and yeah, so on Euron, so now we have implemented a recommendation system. So a system as per the use of your entire Euron ecosystem. So now Euron can give you a recommendation of the courses and the project. So we have even done a cleaning, and then we have now segregated all the courses in a data science, generative AI, so course, projects and books. So in this way we have like a segregated, and our plan is very simple. Our plan is to like create as many segregation technology wise as possible, and then start like loading the courses. So in some of, like for example, build development, right? So we have a very few courses over here, we don't have a project over here, we don't have a books over here. So very soon it will be done. Cloud, we have a very limited one, so we don't have like everything in very detail. So again, we will start loading it. So similarly it goes for like system design, data structure. We have a lot of things for generative AI, at least like tons of project we have, tons of courses we have. For data science and generative AI we have a lot of things. And big data, so anyhow I have launched a series for big data new course series, so you will be able to find out. Plus we have changed the recommendation part. And apart from that, so once you will go inside a courses, so now you will be able to see your analytics part and the certificate part here itself. Yeah. So this is again like one of the implementation that we have done. So hope you all are going to like it, this one. So you can download the certificate from here itself, and then you can see your analytics like from here just by clicking over here from a respective dashboard. So previously analytics was outside, but yeah, so now we are trying to like bring those analytics inside. So these are the small feature update and enhancement that we have done, and now it's live, it's in our production. Soon you will be able to see the update in a mobile device as well, so Android and iOS. So we are going to publish all of these updates in mobile device as well, so that it will be now easy for any one of you to navigate through the entire courses, whatever like you are looking for. And again, we have a super search option. So if I'm searching for anything, right, super search will give you everything. So if I'm searching for, let's suppose, Python, yeah, it is going to filter out immediately everything with that tag. Plus you have like other control as well, so you can search based on the categories and then modes and then like a content type, instructor, author, everything. So a lot of things, it's already there. Cloud your version, yeah, I'm launching a cloud and ops series next month after 15th, because till 15th, so I have already launched a 20 plus courses in a like a hybrid manner. So where as a series we are going to release it. So I'm already occupied for this month and next month. My plate is completely full. So next month I have a plan to launch a AWS series, a Azure series, and a GCP series, plus all the like ops things, whether it's a Docker, Kubernetes, Jenkins, everything in a separate manner. And that too, everything should end towards the like a project basically. So this is something which we already have in plan. So by 15th of next month, we are going to make an announcement. So maybe 1 month from now, you can say 1 month, 4 days from now. And then as per the date, as per the schedule of that series, so we will start launching it. So now we have adopted an approach that, okay, so we have to build basically a OTT platform. So the way OTT platform try to launch a series, right, that, okay, episode number 1, episode number 2, episode number 3. So in the similar manner, so we have started launching. So you must have seen that we have started launching a Python, and then we have released a SQL as well. So video will start coming from Monday, as we have mentioned over here, that one module release every Monday. But we'll try to release multiple modules. But yeah, not like we don't want to get a backlash from your side. So that's the reason. So we have mentioned that one module. But yeah, sometimes so we'll try to release more modules as well. And modules, anyone can see it over here, right? So every Monday we are going to release, and this is going to be like happen for all the series which is going to start. So start date for this one is 10th May, which was like yesterday, and then from Monday onwards. So whichever will be the first Monday. So from Monday onwards, we'll start releasing it. And we have already started releasing for a Python. So if you'll go and check Python Hindi and English, so we have already like started releasing it. So Python schedule is basically MWF, Monday, Wednesday, and Friday. Python with DSA. So yeah, like in this way, I hope guys you all are going to like it basically. And we are like building our book feature. As of now, book feature is a very simple one. It's just a PDF based book feature. No course data is available. Why? Okay. I think they are changing the book feature or something. Okay, let me send this issue to my team. It was working, but maybe they have pushed some changes. I don't know. Yeah, courses are working fine. Only there is a issue with the books, it seems. Yeah, it is sending me URL looks fine, but fine, not an issue. Tech team will check. Okay, so in this manner we are going to release so that we can try to produce as much content as possible. Plus, like I said, so we are working on the book. So I believe within 3 to 4 days you will be able to see very amazing feature, basically a flip book kind of a feature. So where it is going to give you a real time like a readability, and especially we are designing these things for a mobile. So that and again, so we are trying to add AI summarizer, lot of things even from the AI side, audiobooks feature over there. So we are trying to add so that it will be very very quick for you to do a revision, or maybe preparing for the if you're preparing for the interview. So this is something that we are trying to like do as of now. Yes, sir. Are there any comprehensive course on cloud technology like AWS? I recently launched EC2. I recently for the major project, but after stopping and restarting it, MLFlow stopped working on EC2. Although one mentor have guided a CI/CD hands-on experience with AWS platform, could you please assist up with the issue or suggest a further training? I think you have already launched it, right? So you don't need a training basically. So basically you need like someone who can guide you and who can help you out in terms of fixing the issues, because anyhow you are able to launch it and you are able to start it. So just ping someone in a group. I think some people will be able to help you out. We have a lot of people in a group itself, so who is well aware about the AWS and all the other structure, right? So you need that basically. Okay, so now let's start talking about today's topic. So today I'm going to talk about basically, let me search. Yeah. So today I'm going to basically talk about this particular topic. So like I think you all are able to see a topic name inside your like a live class itself. So we are going to talk about a processing. So processing of basically a data. So we have already talked about attention mechanism, transformer, and we'll try to come to the implementation. But before coming to the implementation of all of these things, we need some sort of a text processing. So unless and until we are not able to process, we don't know how to process our data, how to convert it into its vector representation. So we'll not be able to do a practical for any of these things, whether it's a RNN, LSTM, GRU, BERT, GPT, whatever it is, right? Whatever it is. So let's try to do this. And then we have a practical implementation of all of these things. So whatever we have discussed in a theory, so then we are going to talk about everything in a practical manner. So one by one, so I'll be talking about basically a text pre-processing and feature extraction. Then I'll be talking about a tokenization, stemming, lemmatization, stopword removals, and then I'll be talking about a TF-IDF and Word2Vec and globe model basically. So let's get started, guys, and try to open up your VS Code. Try to open up your like VS Code so that we can start doing a coding, and then let's create a folder. So FSDS NLP data processing. Okay. So now let's get started. So here I'm going to create a new file. So I'll be using a Jupyter notebook file, data preprocessing .ipynb. Okay. And now for that, so we can try to create a new environment. So here I can try to do conda create -n -n conda create -n, and then we can try to give a environment name over here. So NLP pre-pro, or let me give some. No, I don't want to create that. So conda create -n NLP. Let's name it as NLP, and then Python is equals to 3.10. Do yes. Okay. So this is going to create an environment for me, and you guys can create this separate environment for this particular lecture. That will be better. So I have just pinged you this in your chat box. Okay, so once environment is created, so just try to activate that environment. So conda activate NLP, and yeah, so we have to select the kernel for this particular Jupyter notebook. So select kernel, and then whatever environment that I have created. So let me search that environment. So yeah, NLP environment has been created. So I'll be selecting this environment for my Jupyter notebook. So I'm just attached this environment to my Jupyter notebook. Now what we are supposed to do, guys, so one by one, so we are supposed to do a text pre-processing. So what is this text pre-processing, by the way? So as we all know that when we are talking about a NLP, so system is not going to understand your words or your sentences or your characters. At the end of the day, system is going to understand only one thing, and that is a numerical representation. So unless and until you are not going to represent everything in a form of numerics, it is not going to work. And this is where this data pre-processing, this is where this tokenization, or this is where this embedding comes into our pictures. Again, the technique which I'm going to show you initially today is an old technique, and we are not going to use those technique in a real time. So because those technique was valid 2 years back, but if I'll talk about our current situation, so those techniques are not valid. Those, like, it's valid, it's still valid, but yeah, it's not effective, I would say. So it's not about invalid or valid, it's about effectiveness. So it's not that effective so far, basically. So I'm going to talk about the old one as well as I'm going to talk about the new one. For example, so we talked about LSTM and GRU. Now LSTM and GRUs are not at all effective. So we have a better transformer based model or attention based model over here. So instead of using those like RNN LSTM, so maybe I can go ahead and use some of these like a transformer based model, which is going to yield a better outcome in any way as compared to this LSTM or GRU based model. But still, like I said, so past is important. Some of the old techniques are important, and these techniques were very much relevant just 2.5 years back. So it's not a very long time since this technique got obsolete basically. So here let's try to do some sort of an import. So I'm going to import a library called as NLTK, the Natural Language Toolkit. So import import NLTK first of all, and then from NLTK dot tokenize, import word tokenize from NLTK corpus, import Stopwords, and then from NLTK stems, import Potter streamer and word WRD, or leave it. Yeah. So this is just an import which we are going to do. So NLTK is one of the libraries which is going to help you out in terms of doing a data pre-processing. I've just pinged you the import, guys. Now, so if I'm going to execute it, it is like yeah. So let it install. So these are the library, guys, that you have to import, and I will be using this library to do some sort of a pre-processing of the data set. So it's telling me that there is no module called as NLTK. So obviously we know the things that if there is no module, so pip install NLTK, execute, and then it will try to install NLTK. As simple as that, right? So it will start installing, and once installed, so yeah, just execute once again, and now it's available. So just do pip install, guys, everyone. Okay, so after learning from you, I have built my own LLM model architecture code, which is giving a good result. May I showcase it in my... Yes, obviously, Dev Kumar, you should. I think I talked about that in your like a generative AI class. So generative AI class, basically it focuses more and more on NLP side of it. It's focuses completely on NLP side of it. So I have already discussed about these things. And like I said, in my recent days, I think 3 or 4 times I talked about the transformer itself in my different classes. So because in every class, like I have to go and talk about the same topic. Okay, so that's amazing. So maybe try to make it better. Try to use some H100 over there or A100 and then like push a huge amount of data and then train it and release it. Now, so here is a NLTK library. I'm able to import and then I can write NLTK dot download DOWNLOAD download. So these are basically some of the predefined, you can say, like a data which is available. So download Punkit, Stopwords, average perceptron tracker, WordNet. So these are a predefined data which is available inside a NLTK library. So people who have built this NLTK library, so basically they have already given a data or stored a data inside this particular library. Now what we are going to do with this, I'll tell you. But yeah, as of now, just try to download these data inside your system. That's it. So this is basically a downloads. Now, here what we have to do is, so I'm going to take one of the data, so which is a text basically. My name is Sudhanshu Kumar. I'm a data scientist. I play cricket, football, all those things, right? So this is the data set which I have taken. Now what I have to do with this data? So I have to pre-process this particular data. Now, what is the meaning of this pre-processing, by the way? So pre-processing simply means that try to maybe tokenize those data, try to break down those data, try to normalize those data. So this is called as data pre-processing, because every model that you are going to build, or like everything that you are going to build, it is going to take a different kind of inputs. The inputs is not going to be same. So keeping that thing in mind, you should know how to deal with those like input and how to align your data with that kind of input. Because when I'm going to teach you that how to build basically your own GPTs, right, from the very scratch, how to train your own GPTs, you will be able to realize that if I'm going to build a four different variety of a GPTs by taking a four different architecture, there are a lot of permutation combination I will end up doing in terms of preparing a data just for that GPT. Depends upon the task, depends upon my end goal. So here I'm taking a text, as you can see, right? And then what I will do is I'll try to convert this entire text into a lowercase. So if there is something which is an uppercase, it will convert everything into the lowercase. So this is basically a way I used to do a normalization. So here I'm just trying to do a normalization. So we all know that what will happen when I'm going to call lower, it is going to convert all the upper cases or whatever is available in upper cases into a lower case. As simple as that. So nothing very like scientific over here, but yeah, a small process which we always try to do. So we are trying to like transform this entire data into a lower case. Now, once I'm able to transform this data into a lower case, then what I can do is I can try to like call word tokenize, and then I can try to pass this textual information. Now, when I say tokenize, right? So word tokenize. So automatically this entire data will be available in this particular format. So as you can see, word tokenize is giving me a list of the data. So where each and every word, right? Each and every word is basically one single token. So my name is, so it is just trying to like split the entire data. This is what word tokenizer is trying to do as of now. Nothing much as of now, right? But yeah, this is what this word tokenizer is trying to perform at this point of a time. This is how I'm able to tokenize this entire data, guys, right? So here maybe I can try to store it into a TOKEN token. Now let me ping you this. So I'm just like trying to basically like convert my data into a small token. That's it, nothing much. Simple. This is again a part of like data pre-processing. Then generally what we do is, so we try to remove the stop words as a part of data cleaning. So we try to remove the stop words. Now what is this stop words, by the way? So here, if you have like seen, so we have downloaded basically this stop words, right? We have downloaded this stop words, and basically this is going to help me out to remove all the stop words from my data set. So for example, if I'm going to show you, so what are the stop words which is available? Stop words dot words and basically ENGLISH English. So these are the stop word which is already available. Where? So the download that I have done. So there is a library inside this NLTK just for the stop words. So there is a bunch of stop words which is already given inside a NLTK. But again, this is not hard and fast. So you can try to create your own list of the stop words. And what is the stop words, by the way? So stop words are the words which is not going to contribute much in your entire sentence. That is something called as stop words. So generally what we do is, as a part of data cleaning, so we try to remove these words from our sentence in general, right? In general, we think that this is not going to contribute much in terms of forming the entire sentence or in terms of giving me the complete intensity of the sentences. So what we do is, so we try to remove these things, as simple as that. Okay. But this is again one single list which you can see over here, and it's not like a standard one. You can try to create your own stop word lists if you want, if you have that kind of a requirement. So here stop words, and let me do a set of it so that it will remove our duplicates automatically. Okay. So stop words, and let me keep a list of the stop_words stop words. So this is representing basically a list of the stop words. Yeah. Now what I have to do is, so whatever data that I have loaded, so this token, so if there is some stop word which is available in my data, I have to remove those things, right? As per the stop word list. So I can write a code for that. Maybe I can write like a loop for that one. So for, I can say, so let's suppose we have a stop words, right? So we can try to write for I in, basically I in token, if I in stop words token dot remove, and let's see, token is not defined. Yeah, looks good. And token is already defined. Name token is not defined. Why? It's okay. So token dot remove, and see what I have done. I have not done like a much over here, as you can see. So what I have done is that whatever data that I had, the original token that I had, so I have to remove the stop word. So I have just written the loop over here for I in token, if I in stop words, right? So whatever data which I am trying to parse through a token, if that is available inside the stop words, right, remove it. As simple as that. So I'm just trying to do a data cleaning operation from my actual data. So as you can see, there was my name is Sudhanshu Kumar, right? So my is gone, is gone. So I'm just trying to perform some sort of a data cleaning as per the stop word list that I had. If I would like to add maybe like this dot inside this full stop inside the stop word list, I inside the stop word list, am inside the stop word list, a inside the stop word list, I can do that, right? Because at the end of the day, it's just a list, right? It's just a list. So stop word is nothing but just a list basically over here. So in this way, I will be able to do a data cleaning operation. Here I'm trying to use a corpus which is already available, but yeah. So instead of doing that, maybe I can try to create my own. That's completely fine. Making sense, guys, to all of us? Yeah. So nothing much. I'm just trying to show you a approach. This is not a hard and fast rule that you should always do this. No, I'm not saying that. Yeah, fine, everyone. So basically, I will end up removing the stop word. So again, just a simple for loop which we are running over here. Now coming to the next part. So there is something called as stemming and lemmatization. So let's try to understand that particular part as well. So there is a stemmer called as Potter stemmer. So there are a lot of like a stemmer which is available out there. So I can try to use maybe a Potter stemmer over in this particular place. Now, so I have this token, this entire token, so which I'm able to extract. Now I'm going to call basically a stemming. Now what is the meaning of stemming? So very soon you will be able to understand. this entire stemming part. So here I'm going to write for I in a token. So just try to do a stemming on top of this. Now here, so when I'm trying to call a stemmer, right? So when I'm trying to call this Potter stemmer, which is an inbuilt library. So what this stemmer does that it will try to chop off some of the information. So here, if you are going to do a comparison, so names Sudhanshu Kumar, data scientist, love play cricket, football. Names Sudhanshu Kumar, data scientist, love play cricket, football. Double L is gone, right? Double L is gone. So basically this stemmer, so what it try to do is it will try to bring a data in its lowest of its format. This is what a stemming does. Now, similar things you will be able to find out even from a lemmatization. For example, so I'm going to write for I in token. So I have to do basically a lemmatization. So, okay, let me create a lemmatization. WRD word net lemmatizer. Okay. So now, as you can see, so this stemming and lemmatization is trying to perform almost like a similar kind of operations for me. And here, so what it does is that it will try to like reduce, or it will try to remove all this ing or as or like many more things from your data set, so that your data set will be available into its lowest format. This is what stemming and lemmatization does. So stemming wise, you can try to use a Potter stemmer. Lemmatization wise, so you can try to use a WordNet lemmatizer. The objective of both of this is to bring down a data into its lowest format. For example, if there is a running, so it will try to convert that thing into a run. If there is a processing, so basically a stemming will try to convert that into a pre or process basically. And this is what this stemmer is going to do basically. And then lemmatizer, so lemmatizer will not do much of that. So basically it will not try to convert much of this ing or as into its original format. But yeah, at the end of the day, it is just helping me out to bring down the data into its original format. Nothing much as such. Now, coming to the next part, let me ping you this code, stemming and lemmatization. So I'm doing this stemming and lemmatization on my own token that I've created. Copy this once again. So I'm just trying to like not doing much. You can even try to take maybe one of the data. For example, so if I'm going to call this lemmatizer, so maybe I can try to pass my own data over here, and I can even try to check. So here RUNNING running. So it's running itself. And then if I'm going to use maybe a stemmer, so it is going to convert it to run. So even just by passing one data, RU running. So converting into a run, as you can see, RUNNI. So run, right? So it is just trying to convert this data into a lowest format. This is what stemming and lemmatization does. Apart from that, it is not doing anything. It's again a part of the data pre-processing, so that I can try to like bring down the data into its normal format. Now, moving to the next. So these are just a part of your data pre-processing or data cleaning. Maybe bringing down a data to its like a normal format, so where everything is available into a lowercase. Part number 1. Part number 2 is removing all kind of stop words. Part number 3, implementing some sort of a stemmer or lematizer on top of the data set. So these are just a data pre-processing in terms of textual data, right? So when we say again, so stop words wise, stemming lemmatization wise, or maybe like a lowercase conversion wise, you just have to make sure that at the end of the day, you are going to achieve a very clean and generalized data. This is the whole idea. This is the whole objective behind this one. Now, once we are able to do that, now it's time to convert my data into a numerical representation, because before sending my data to a neural network, unless and until my data set is not available in a numerical format, I will not be able to use it. And that's a problem, right? I will not be able to use it because system will not be able to understand all of this information. It will not be able to build a relationship between these information. So I have to convert it to basically a numerical format, and this is where the vectorization part or embedding part comes into a picture. So where I will be taking a data and then eventually I will be converting those data into its numerical representation. For example, I'm going to take the data. Let's suppose I'm going to build my own data. So here is a list. Inside this list, I'm going to keep a couple of data. My name is Anshu Kumar. Then I love playing cricket and football. I'm also a good singer, which I'm not, by the way. Yeah. So this is the data which I have taken, as you can see. So this is my data which I am going to take. Now go implement this stop words, go implement those lemmatization, go implement like convert this entire data set into its like a lowest format or whatever you want. You can just do it. But after doing that, I have to convert this data into a numerical representation. So now let's try to convert this data into its numerical representation in a step-by-step manner. So there are multiple approach. It's not like there is only one approach. There are multiple approach by which you will be able to convert this data into its numerical representation. The very first approach which I am going to talk about is basically a worst approach, I would say, right? As per the today's scenario, it's a worst approach. But yeah, I think you should know about it. There is something called as bag of word approach. So let me import first of all like a bag of words. So sk learn feature extraction text, and then import counter vectorizer. Yeah. So counter vectorizer, and it's saying no module called as sklearn. Okay, not an issue. So pip install and not nltk sklearn. Execute. So it will be able to install pip metadata generation fail. Okay, so maybe let me check what is the pip for this. So scikit-learn. So this is basically a pip, actual pip for this one. So just install this, guys. Yeah, Durgesh, I have done that. Okay, so now sklearn is done, right? So we are able to import and install this scikit-learn. Now let's try to import this, and this time import is working, right? So counter vectorizer, we are able to import it. Now I have a data, right? I have a data. So basically this is the data, and eventually I have to convert this entire data into its numerical representation. That's a whole idea behind this entire things, right? So what I can do is maybe I can try to call this counter vectorizer object. So let's create the object for that vectorizer. So this is the object which I have created. Now this object vectorizer dot fit, and then I'm going to pass my data, the same data, right? This data I'm going to pass over here. And then let's see, so what is going to happen. So it is able to fit into my counter vectorizer. Now, so let me store this data as maybe like a X data after doing this vectorization. And this X is nothing but it's an object of this counter vectorizer, as you can see. Now here, so X dot to array to array to array is going to showcase the data, but it is not showing why. It should show me the data, by the way. Counter vectorizer, I'm passing a data, that's completely fine. And to array. No, it was working. I have already tested it just before your class. It was working, by the way. So vectorize dot vocabulary. Let me print that part. It's working. So my this. It's working perfectly fine. And if it is working, okay, maybe I have not executed this, but x dot to array. Okay, so fit transform. Maybe I have to use fit transform, and now it is having a array. Okay. So this is, as you can see, guys. So I had a data. This data, right? I had this particular data, and now this counter vectorizer. So basically, it is able to convert my entire data into this particular format. Yeah, into this particular format. Now you must, and this is the complete numerical format. Yeah, and now I can pass this data one by one, one by one into the neural network. That's completely fine. So now my data is eligible enough to get passed into a neural network. But how we are able to generate this data and how this counter vectorizer is working, and technically counter vectorizer is basically behaving as a bag of word. Basically its algorithm name is basically bag of word. So how it is working, let's try to understand that particular part first, because that understanding is very much important, and then you will be able to create like that if you have like that understanding. So let's try to understand. So what this vectorizer does is, so let's suppose if I am passing this data, this is my original data where I had, my name is Anshu Kumar, I am a data scientist, I love to play cricket and football, all those things. So these are the 1111 sentences that I have taken. Eventually, I'm trying to convert all of my sentences into its numerical representation. Now, what this counter vectorizer does is that in a backend, so it tried to implement an algorithm called as bag of word, right? Now, what is the meaning of this BOW, bag of word? Sometimes some people used to refer that as a bow, bag of word. So what is the meaning of this bag of word, by the way? Very simple, right? It's very simple, very basic algorithm, I would say. So here bag of words simply means that let's suppose I have passed this particular data. So first what it will do, it will try to go through this entire data, the selected one or whatever data you are going to pass. It is going to find out the total distinct data. For example, here, so when I have said vectorizer.vocabulary, so you will be able to find out that it is trying to list down the total distinct data, right? Total distinct data. And total, how many data set we have? So 0, 1, 2, 3, 4, 5, 7, 8 till 15. Can I say we have like a 16 distinct data over here starting from 0? So it has given a number, random number, not random number, starting from 0 basically, right? So total, how many distinct word we have, distinct data or distinct word we have or distinct token we have inside this entire corpus? So basically we have 16 starting from 0 till 15. So what it will do is that it will try to create a array, right? It will try to create a array of length 16. It will try to create an array of length 16. So you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, okay, 17. So maybe we have 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, fine. So it's a 17. So maybe we have like a 17 data. I don't know. I'll have to check. Right. So 17. Okay. We have something till 16. Fine. Got it. That's the reason. So it's a till 17. So fine. I have just like, I thought that we have just till 15. So we have 16th as well. So in total, starting from 0 to 16, so basically in total we have 17 distinct data over here. So what it will do is that it will try to create this 17. And how many records we have? So 1, 2, 3, 4, 5, 6, 7. 7 records. So as you can see, we have a 7 arrays over here. 1, 2, 3, 4, 5, 6, 7. So one array for one line with a dimension. What is the dimension of this? So dimension of this one is basically a 17, right? How it is able to get this dimension? So dimension bag of word will be able to get from total number of the distinct word. Is it making sense, guys? Yeah. How it is able to get the dimension? What was the dimension, by the way, in the research paper which I have discussed yesterday? Any idea? I think we talked about a dimension, d of k. Yeah, what was the dimension, by the way, guys? Research paper that we have discussed. 512. Yeah, that's correct. 512. So see, even dimension matters a lot. So this is where like we talk about, they were saying 64. No, it's not 64. It's a 512 basically. Please go and check once again. It's 512. Yeah. So basically how it is trying to create a dimension, and dimension always matters. So believe me, dimension always matters. So whenever we are talking about this NLP vectorization or converting some data into its embeddings, so dimension always matters. So here bag of word, how it is trying to decide the dimension, it is able to decide it based on the distinct number of data or distinct number of keywords inside your corpus. As simple as that. So we had starting from 0 till 16. So okay, length is basically 16. So now there is a 17 placeholder here, 17, 17, 17, 17, 17. Now how it will be able to create it basically. So it is going to create an array. Let me just show you in this way. So it is going to create an array. So here, let's suppose it is going to create the array. So ALSO also, right? Then am, and then where is the second one? AND, and third one cricket, fourth one data, fifth one football, and so on, right? So this is basically a column, you can say. This is the column it has created. This is the column it has created. Okay, this is the column it has created. And then after creating this column, after doing this, so what it will do is it will simply go to the data, right? It will simply go to the data. So this is my original data. This is my original data, right? So also it will just start giving 0, 1, 0, 1. So also is available in, so it will look into this first data, right? Because I'm trying to create a vector for this first. And now we have 17 columns, right? We have 17 such columns. As you can see, we have 17 columns in total. So what it will do is it will go to the very first one because it is trying to vectorize the very first one. So also available in this entire corpus? No, 0. Am available? So am, yes, 1. And available? So and available? No, 0. Cricket is available? Cricket is not available in the first one, 0. Data is available? Data is not available in this one, 0. Football is available? Football is not available in this one, 0. So whatever is available, give it as 1. Whatever is not available, give it as 0. Is it making sense? Yeah. So for first corpus, for second corpus, for third one, for fourth one, for sixth one, seventh one, and so on, right? So it will keep on doing this, and this is something called as bag of word, BOW, B-O-W. Are you able to understand it, guys? What is the meaning of BOW? Yes, guys. Yeah. So this is how like it is basically going to create this entire like this array that you are able to see, right? And then dimension that you are able to see. This is how it is going to decide. So this is one way of converting my data into its numerical representation. Now I can send this entire data for a training purposes. So data number 1, then 2, then 3, then 4, and so on. I can try to send it. But there is a problem with this representation. The problem is very simple, that it never try to convert, or it never try to think about a grammar. It never try to think about the punctuation in between, right? It never try to think about which is going to come first and then which is going to come second. It never even think about a relationship in between the data set itself. For example, like my name is. So it will never be able to understand what is the relationship between this my name is, right? It's a very simple, straightforward one-to-one mapping that system try to do. That's it, right? That's it. So this is not very much ideal, I would say, for like my heavy data set. This is not at all ideal, I would say, for my heavy data set. It is going to fail at some point of a time. And that's a problem with this one. Then people have started thinking about a better approach, that can we try to develop a better approach than this one, like the one that we are talking about. And then people like came up with a different idea that, okay, so we can maybe try to find out the better approach. So let me talk about a better approach than this one. But again, I'm not saying a best one. Best one I'll show you at the end. So better approach than this one was a TF-IDF, a term frequency document, inverse document frequency. The algorithm name was TF-IDF, term frequency, inverse document frequency. Let me show you an example for that. So from this one, TF-IDF vectorizer TF-IDF, and then here, so I'm going to pass my data, give me the vocabulary. So there is a library called as TF-IDF, and I'm just trying to call that library, as you can see, calling fit transform, and I'm just trying to show you this entire vocabulary, that this is the vocabulary starting from again like 0, 1, 2 till 16. Okay, same data I'm taken. I'm not like changing the data, by the way. Yeah. Now, so here, if I'm going to print x dot to array, x dot to array, so I will be able to see the data in this way, right? I will be able to see a data in this way. As you can see, even here, my objective is what? Even over here, my objective is to convert my data into a numerical representation. But here, you will not be able to see like a 0, 1, 0, 1, 0, 1, 0, 1 kind of a things. Here you are able to see something little bit different. So let me show you, or let me talk about this, that how we are able to produce this particular information. Again, very simple. It's very simple, means literally very simple in terms of like doing a calculation, in terms of doing a math. So let me do the math for this one. So like I said, this algorithm works in a little bit different way, and this algorithm name is basically called as TF-IDF. So its full form is term frequency inverse document frequency. This is the name of the algorithm. Now, how this algorithm works? So for every data, it try to find out TF first of all, and then it will try to find out IDF, multiply it, right? Multiply it. And this is how it will be able to like get a TF-IDF for a particular data. Now, what is a TF, by the way, right? So this is nothing but, TF is nothing but a count of, COUNT, count of a term in document divided by total number of terms in document. And what is the IDF? So IDF is nothing but a logarithmic of total number of document divided by 1 plus, you can say. Some people try to keep 1, and then some people not try to keep 1 just to remove the 0 error over here. So divided by number of document containing term. So this is a very simple formula which has been given, and this, based on this formula, you are able to see below matrices. The below matrices, the below conversion for every sentence that you are able to see over here. So it's coming from that formula itself. Now let's do the math for some of this data. So here, what TF-IDF says. So TF says that count, like a count of the count of the term in the document, right? So for example, if I'm trying to like convert this into its numerical representation, a very first one into this numerical representation. So how I will be able to convert my into its vector format, name into its vector format? Let's try to understand. I'll do a couple of things over here just to give you the explanation out of this entire things. So here, let's suppose I'm targeting my, yeah. So I have to convert this my into its numerical representation. So for my, I will try to calculate a TF, right? TF for my, I'll try to calculate, and IDF for my, I will try to calculate, and then multiply. And that is going to be the numerical representation of my. So how I can do it? So what is the TF? Count of the term in a document. Document is nothing but one whole sentence. It's called as document, right? This, so we have in total 1, 2, 3, 4, 5, 6, 7. So we have total 7 documents, by the way. Yeah. Terms is nothing but our respective tokens I'm talking about. So count of terms in the document. So how many times my is appearing in this entire document? So only one time my is appearing. Okay, one time, right? Divided by total number of terms in the document. So how many total number of data terms we have in the document? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total 11. So TF is basically 1 by 11. And then what is the IDF? IDF is nothing but a logarithmic, right? A logarithmic. Logarithmic of what? So what is IDF? So IDF is nothing but a logarithmic. Logarithmic of what? So logarithmic of basically total number of documents. So what is the total number of document we have? So total number of document we have is equals to 7 divided by 1 plus number of document containing this particular term. So how many document is containing this my term? So this second one not containing, third one not containing, fourth one not containing, fifth one not containing, sixth one not containing, seventh one not containing. So 1 plus 0. Now just try to multiply TF and IDF and you will be able to see. Now we have a numerical representation, right? So 1 by 11. So its numerical representation will be 1 by 11 into logarithmic of 7 divided by 1. So technically it's a 7. So now this is going to represent technically your word my, right? This will be the representation of a word my. Now, one thing you should like focus a little bit over here, that how this is going to be a better than bag of word. So because bag of word was just like trying to do the mapping, right? So if this data is available, do 1, otherwise do like a 0. This is what it was like trying to do in case of bag of word. Now here, in case of TF-IDF, you will be able to see that it is trying to establish some sort of a relation at least between a particular token and the rest of one in terms of TF, right? Term frequency. Also, it is trying to do some sort of a relationship building with respect to this token and the whole data, whole document you can say. So for every word, somehow we are trying to relate with the like a data in the document itself plus a data or token with all the other document which is available in the corpuses. So somewhere this is going to give you a better relation, a better numerical values, right? Better relative numerical value, I would say, as compared to bag of words. That's the reason. So I'm trying to say that this one is a little bit better as compared to, I'm not saying that it's the best one. No, not at all. Not yet. But it's a little bit better as compared to the bag of word. Is it making sense to all of us, guys? Yeah? Making sense? How this is better? And how to find out TF-IDF, by the way? Yes, guys? Yeah? Okay, so now I think I can try to extract one of this data. So maybe from 0th, I can try to extract it. And then maybe I can try to like check the length. So length of one of these vector, right? Length of one of these vector is going to be 17. So for all the vectors, length is going to be 17 because see, whenever we are trying to do the vectorization, right? So always we have to make sure that length should be constant. Your doesn't, because see, if you look into your sentence, some sentences is having a 10 tokens, some sentences is having 4 tokens, some sentences is having 5 tokens, some sentences is having some different tokens. Now, this is not going to work when you are going to give a input into a neural network. Yeah, this is not going to work when you are going to give this input to a neural network. So you have to make a constant vector size. So for every neural network, we always try to create the constant vector size, because someone will come over here, someone will give 100, someone will give 1000 tokens. Now that is not going to work. That is not going to work. That is not going to help me out in terms of understanding the relation. Now, keeping that in mind, right? So keeping that in mind, we have to create a constant vector size. Now, so every algorithm is having its own logic. Logic wise, so what should be the vector size? It's exactly same as bag of word. Try to find out the distinct words, and then that is going to be the vector size. As simple as that, right? So whenever it is going to calculate a TF-IDF, very simple, right? So let me write it down. Also at 0, and then like a 2 and sorry 1, right? So am, and then and then the third cricket, and so on, right? So we are going to create a columns. We are going to create a columns, right? In case of bag of word, what we have been doing, we have been giving 0 1 0 1 0 1 0 0, something like this, right? In case of TF-IDF, so if this data is available in a particular like a document, then try to calculate its TF-IDF, calculate its TF-IDF. It's not available, then give 0, simple. Anyhow, TF-IDF is going to be 0. If it is not available, just try to calculate TF-IDF, right? So for example, for also, right? Also as a keyword, if I'm going to calculate a TF-IDF, let's see what is going to happen. So for also, if I'm going to calculate a TF-IDF for this very first document, what you will be able to find out is a count of term in this document. So what is the TF? So TF is nothing but in a numerator, count of the term, means count of also in the very first document. 0 divided by anything and multiply by anything is going to be 0. So eventually it's going to be 0, as simple as that, right? So the way we were trying to create the matrices in a bag of word it's the same, but yeah, so in case of bag of word, we were giving 0 1 0 1 0 1 based on the availability and non-availability. Here we are not doing that. Here we are trying to calculate TF-IDF, as simple as that. It effectively highlights the most important and distinctive terms in the document. Yeah, it's not that effectively. It was very much effective 2 years back, like I said, but in last 2 years, a lot has changed in NLP. And so, okay, my team is saying that they have fixed the book issue. Let me check. Yeah, they are working even on Sunday like me. It's working now. So this is what I was trying to show you guys, that we are trying to bring a very amazing feature like a flip book feature over here. And then we have a plan to release like a 500, 600 books back to back, back to back, back to back for everything, right? And that too with a flip book feature, book summarizer feature, many more features, basically, many more AI feature we are trying to build around it. Audio feature also, we are trying to bring content wise. Okay, yeah, it's been fixed. Okay, so TF-IDF, I think we are able to understand term frequency, inverse document frequency, and what is the purpose behind it. Yeah, so anyone who is having any kind of a doubt with respect to the purpose that we are talking about here, guys? Yes, no, or like, don't know. Yeah, all clear. Okay, so this was better. I mean, like TF-IDF was better as compared to bag of word that we have discussed. But like I said, it's not the best, right? It's not the best. So now what we are going to do is, so we are going to discover some other technique, and that some other technique is basically called as word2vector. So which is basically a neural network based technique, because I want, see, system will be able to learn better and better if you are going to give a better matrices. If you are not going to give a better matrices, system will not be able to learn. And even the architecture that I have discussed yesterday, you must be able to see that starting point was embeddings. Means embedding means you have to convert your data into a numerical representation. So without fixing this problem, right, to generate a best of best embedding, you can't move to the next step. Basically, that's a very first and foremost logic and rule that you have to implement. Doesn't matter what kind of an NLP problem that you are trying to solve in this entire world, right? So this is one of the crucial problems. So people said that okay, so let's do one thing. So let's try to find out some neural network approach, so where system should learn and then system should basically give me the final output, right? Final output means a vector, obviously, right? This is something called as final output. So neural network approach, and they have designed a very simple neural network, a one single layer neural network with a hidden layer, that is something called as word2vector, right? Word2vector. Now, so inside word2vector, so again, there are two techniques which you will be able to find out, and that is basically called as skipgram and CBOW, continuous bag of word, and there is something called as skipgram. Let's try to understand that one by one, right? And let's try to see how we can try to do the implementation. So I'll be using same data, the data which I have prepared. So I'm not going to use like some other data. Let's try to use the same data. And let's try to understand how we can try to do the implementation of word2vector. So here, what we can do is we can try to import library called as gensim. And then from gensim model, import word2vector from tokenizer. And yeah, data is like same. So I'm going to use like the same data that I have. So I'm not going to change the data, by the way. Now it's telling me that no module name gensim. Okay, not an issue. So pip install 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 and then gensim. Run it. Oh. So run it, guys. Okay, so seems like I'm able to install. Let's import, and there is an issue. This gensim always gives an issue. So what is the issue? NumPy issue. A very known issue for this gensim. It always gives us issue with respect to a NumPy. Nothing new. Okay, this done. Let me check once again. NumPy issue again. Let me try upgrading this gensim. Requirement already satisfied. Then let me try upgrading NumPy. There is a known issue, guys, all the time. Like I don't know like why it gives an issue, but yeah, it gives an issue. Gensim, this is required numpy somewhere between lesser than 2 or greater than 1.185, but you have numpy 2.25, which is incompatible. Okay. So numpy version I have to degrade. This is what it is trying to say. So just do one thing. First of all, uninstall my numpy from this environment. Successfully uninstalled. Fine. And then pip install numpy. 1 point. Let me give 1.8. May not need to start the kernel to use the updated package. Subprocess exited with the error. Let me uninstall this. Okay, so restarted the kernel. Let me. Okay, still gensim. No module name numpy. Restart. Worked this time, guys. So there is a package dependency for a numpy basically, and this is going to irritate you all the time. Nothing new basically for this one. Nothing new, at least for me. Whenever I execute, so it gives me this issue. So it is looking for a lower version of numpy. So install it and then restart the kernel, and then it is going to work. So gensim is basically, guys, a library, so which is going to help me out in terms of like implementing this Word2Vector implementation. So from gensim, as I have already restarted my kernel, so everything is gone. So let me re-execute everything once again. Yeah. So I'm just trying to re-execute everything once again. Okay, all good. Everything is working. Now, so gensim, just try to import this gensim and then try to like do your setup with respect to a numpy. Then what we are going to do, so then we are going to see the implementation. It's not very tough, I would say, but yeah. So let's try to see the implementation. So we have a data, by the way. Objective is to convert this data into a numerical representation. Same objective before, like before. So my objective is not very different. So here what I can do is for I in token, right? So for I in token, what I can do is, so I can try to call for I in token, I can try to call a word tokenize I. Now, so what this word tokenize I is going to perform? So basically it is, and let me create a list over here, tokenized tokenized data. Tokenized data, and tokenized data is equals to tokenized data dot append, and append this into my list. Okay. So here I will be able to get a tokenized data, as you can see, right? So tokenized data I'm able to get in this particular place. Now, once I'm able to get this entire tokenized data, names Dhanshu Kumar, data scientist, everything, it looks a little bit off. Yeah. Now it's fine. It was looking off a little bit. So I'm able to like tokenize this data, as you can see. So this is one data, this is the another data, this is the another data, this is the another data, and so on. So I have basically like 7 records. So 7 records I'm able to prepare, as you can see. Yeah, all 7 records has been prepared. Now what I'm going to do is that I'm going to basically send this entire data into a Word2Vec model basically. So Word2Vec model, the model which I have done as an import. So inside that I'm going to like send this entire data set. So how I'm going to send this entire data set? As you can see, so I'm going to send this tokenized data, and then there is a vector size I'm trying to define is equal to 100. Window size is equals to 5. I'll be talking about windows. Minimum count is equals to 1 and worker is equals to 4. And why it is trying to give me autocomplete for this one? Maybe I can name it as a model here. Okay. Then skip gram. So SG is equals to 1. Okay. Now, so this is going to be responsible. This is going to be responsible for converting my entire data into a vector. So just execute it, guys. First of all, this tokenization, and then I'm going to give you the explanation about the Word2Vector. So this one and this one, just build the model, and then in 1-2 minutes, I will be able to explain you that what it is doing. Done, guys, everyone? Yeah, execution done. Okay. So now let me talk about that how this entire things is going to work, and let me even show you that how like it is behaving. So here I'm going to call model, and then I'm going to like call data, or I'm going to call Sudhanshu itself. Sudhanshu was a part of data. So now you can see that it is trying to do a representation, right? It is trying to do a representation, and it is representing just one single word, which is Sudhanshu, right? With 100 vectors, one single word. Just imagine one single word. It is trying to represent with these many data, right? Or these many like a vector, or vector size is equal to 100. Now, how it is trying to learn, how it is trying to represent, what is the meaning of all of these things? Let's try to talk about one by one. Like I said, it's easy, but yeah, it's a neural network based approach where, so we are sending our data, it is trying to learn each and everything, and then eventually once learning is going to be complete, so you can keep on passing one single token, and this is very close to the way we try to do our embeddings today, or vectorization. The vectorization embedding is same thing basically. So it's very close to the approach that we try to implement in today's environment by using a neural network or transformer based model. So this is where like this particular stuff is very much important. So let me give you the explanation of these things. So here a Word2Vector is nothing but it's a neural network, like I said, right? It's a neural network, and I think we all understand what is a neural network, right? So there will be a weights and there will be a biases, there will be an input and there will be the output. So we are going to give an input, it is going to give me the output. Now here, so Word2 vector is basically a model which is, or model architecture you can say, which people have already defined. Inside a GenSim library, I'm trying to pass a data, a tokenized data I'm trying to pass. As you can see that in my tokenized data, so I have a list and then I have a tokens, means I have a word, English words. So I have a multiple list, or you can say multiple documents I have. So that is something called as tokenized data. It's my own data I'm trying to pass. Now vector size, right? So like I told you, even in TF-IDF and bag of word, that size matters, because every sentence will not be having a similar representation, right? Every sentence will not be having a similar representation at any point of a time. So keeping that in a mind, so we have to make it constant, that it's not like some vector size will be 5, then 2, then 15, and then 200 and 2000. No, it should not be like that. Vector size should be constant, means everything when we are going to represent it in a numerical format, it should always be constant, means it should always be constant. For example, in case of transformer architecture that we have discussed, it was 512. So this is what is called as a vector size over here. So here I'm trying to control a vector size. I can try to keep it 100, or maybe I can try to keep it 200, 2000, whatever I want. I can try to keep it as per my own need. So this is something called as vector size, and this is basically a trainable parameter. So I can try to reduce it, I can try to increase it, right? Now there is something called as window is equal to 5. So I can try to give window is equal to 5. I can try to give window is equal to 2. Whatever I want, I can try to give it. Now, what is the meaning of this window, by the way? So meaning of this window is very simple. It says that maximum distance between the current word, the word that you're talking about. For example, Sudhanshu I'm talking about, right? So the maximum distance between the current word and the surrounding context word. So this is something called as a window. I'll give you one example, and with the help of example, I'll try to explain you. Otherwise, you will not be able to understand these things in a better way. So let me give you an example of that how it is going to do the math basically. So let's suppose if I'm going to pick a sentence called as Danshu, right? And window size is equals to 2. For example, I have selected. Yeah. So window size is equals to basically 2 I have selected. Now, so let's suppose there is a center word is, which I'm going to choose over here. So let's suppose input I'm going to design. So input is basically is, and output is basically a context. So output is basically my name, Dhanshu. Yeah. So here what it will do is, so if window size is equals to 2, it will start taking a pair. Pair means what? So pair means it will start taking is name, is my, is Sudhanshu. So it is going to create a pair is name, is my, is Sudhanshu. So this is the meaning of a window. This is the meaning of the window. So if I'm going to consider window is equals to 2, if I'm going to consider window is equals to 5, so in that case, it is going to create this one with a 5. So this is what the meaning of the window is in this particular place. Hope all of you are able to understand this particular part. Now, so what is the meaning of this minimum count, by the way? So minimum count is nothing but minimum count is equals to 1. So I'm trying to say that try to ignore, right? Try to ignore all the words which has appeared just only once in my entire corpus, right? In my entire document. So if some word is appearing only once, don't consider that word at all. Don't consider that word at all. Worker is equal to 4 means I'm trying to introduce a 4 CPU over here. So whenever this training is going to start, so I'll try to spin basically a 4 CPU. and then SG is equals to 1. So inside this word to vector, there are two different kind of models you will be able to find out. So one model is basically called as skipgram model, skipgram based model, and one you will be able to find out a CBOW, continuous bag of word model. So if you are going to keep skipgram is equal to 1, so skipgram based architecture will be involved. If you are going to keep skipgram is equal to 0, by default it will be 0, by the way. So it is going to be a continuous bag of word architecture. So there are two architectures, so which has been represented by 0, 1, skipgram and CBOW. This is what it means. Now, so if I'll talk about specifically about a skipgram, right? So how like a skipgram actually works. So let me give you one example. So let's suppose there is a sentence, right? There is a sentence. The teacher guides the student. The teacher guides the student. Now this is my sentence, by the way, right? This is my sentence. Let's suppose I have kept a window size is equals to 2 as of now, right? Window size is very much important. So window size is equals to 2. I have kept over here. Now, so let's suppose a center word is going to be, let's suppose a guides over here. So how skipgram is going to do? So skipgram, always based on the window size, it will try to generate a training pair. So when I say window size is equals to 2, so 2 pair it will try to generate. If I'm going to say window size is equals to 3, so from the center word, it will try to generate a 3 pair, guide the teacher, guide the student, guide teacher, the student, something like this. It will try to prepare. So this is the meaning of a window. So this window always try to help me out in terms of preparing the entire training data, which I'm going to send inside the neural network. Now coming to the next part, basically, right? So how this CBOW is going to work, by the way. So continuous bag of word, if I'm going to talk about, so here it is going to create a training pair based on the overlap, means based on the continuous word. For example, if I am going to take maybe where is my corpus? Yeah. So my name is, then name is Sudhanshu, then is Sudhanshu Kumar, then Sudhanshu Kumar and, then Kumar and I, then and am I, based on the window size, right? Based on the window size. If my window size is equal to 3, in that case it will be that. If my window size is just 2, my name, then name is, then is Sudhanshu, then Sudhanshu Kumar, then Kumar and I, then I am. So this is going to be a training data, by the way, it is going to create at the end of the day. So this is the meaning of each and everything, guys, by the way. Now, once it will be able to train, right? Once it will be able to train, now you can find out that once model will be trained, and I can change all this parameter basically, right? I can change all this parameter the way I want. So once this model is trained, I can try to pass a data and then I can try to generate its respective vector. As simple as that. I will be able to generate its respective vector representation. So every single token will be represented with this vector size. If I'm going to say that don't use this, just try to represent it with the 20 vector size. So now you will be able to find out that every single word, whatever word that you are going to pass, which was the part of your corpus, it is going to represent it with that vector size. So this is how it is, guys. So everything is under my control, and it's a neural network based approach. You all will be able to find out. Is it making sense to all of us, guys? Yeah. So now what is the advantages you will be able to find out? So the very first advantage is it is obviously a neural network based approach that we have taken inside this one. The second one is a lot of parameters under my control, vector size, windows, which is going to decide overlap, minimum number of count, which is going to help me out in terms of keeping the words. If the frequency of the words is very less, I can control that as well. Right. I have two architecture. One is a skipgram based architecture. One is a continuous bag of word based architecture. A little bit different in terms of creating the training data. And apart from that, right? Apart from that, so when I'm trying to introduce a neural network based approach, it learns basically, right? It learns a relationship with the overlaps and with the pairs. It will always try to learn. And then it will try to give you this particular vector information, the vector that I'm trying to train. Let's suppose vector of length 20 as of now. Maybe I can try to make it 200, right? So in a very, very high dimension, you are trying to represent one single data, right? In a very, very high dimension, and that dimension you are trying to control. So here I'm using 20 dimension to represent one single data. I can make it 200, right? A 200 dimension in which I can represent just one single token. So when I represent any data in a very, 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 very high dimension, so it gives me a lots of flexibility in terms of like learning a distance or a relations. This is one of the biggest advantage you all will be able to get. And yeah, so like based on that, you can try to prepare your data. You can try to send your data to basically like a next model where you can try to train this entire model. So this is where this entire approach, a bag of word approach, or maybe like a TF-IDF approach, or word to vector inside that skipgram and CBOW approach comes into a picture. At the end of the day, our objective is to convert my data into its numerical representation. That's it. This is the only thing that we are trying to do as of now. Fine. Okay. So this is one of the way, a neural network way. But again, this became like old. This is not that effective because a neural network itself was very, very simple. So then people have started talking about even a better and better and better approach. So then they came up with the idea of a transformer based approach. The approach that we have discussed yesterday, that why can't we use a transformer model, which I can train on a very, very big data set, right? And then I will try to use that to generate the embeddings for me, or to generate this vector for me. Now, this is where a lot of embeddings model you will be able to find out there in a Hugging Face. Now, the best part is that if you will go to Euron and if you'll go to Euri, if you'll click on APIs, if you'll click on available models. So we have even released the standard one from OpenAI itself. So we have released a text embedding 3 small model, which you can try to call, and then you can convert any data into its numerical representation. And this is the standard approach nowadays we all are following, right? So we are trying to use some of the transformer based model itself, because we know that data will be trained on like a very high data. Let's suppose for example, this word to vector we have, right? So instead of Sudhanshu, I'm going to write maybe like Durgesh. Now see, this is the problem, right? Now what is the problem, by the way, with Durgesh? So this word to vector have not seen this word called as Durgesh. The problem with this Durgesh is that I have created the model, I have created the word to vector, right? Sudhanshu was there, I am, all those words are there. But if Durgesh is not a part of this entire Word2Vec or my corpus, the data that I have prepared, right? This is my data. There is no Durgesh over here, right? This was my data. Now crashed. It is not able to give me the dimension. It is not able to give me the dimension. It is not able to give me the embeddings basically for Durgesh. That is the problem, right? That is the problem, because it will always work with your own data on which you are going to train. I need something which will be able to, or which should be able to give me like embeddings for everything and anything. Yeah, out of vocabulary problem. Exactly. Yeah. So unless and until I'm not going to make Durgesh as a part of my data and then going to train it, it is not going to give me the response. That's a very big problem for me, right? A big problem for me, because there are like millions of like different permutation combinations of a vocabulary which is available out there, and that too in one single language. If I'll talk about maybe other languages, so again I will be able to find out another millions and billions of the combinations, right? Now that was the real problem which we were facing. Now keeping that in our mind, they said that okay, so we can try to use a transformer based model, because these transformers that we are trying to train, the big model that we are trying to train, it is aware about all the data, right? It is aware about all kind of a vocabulary and tokens. And again, so its neural network architecture is very relevant and very strong. So this is going to give me a better embeddings, right? A better embeddings. So this is going to solve your OOV problem, a out of vocabulary problem that we are facing, and as you can see in my screen right now. Yeah. So this is going to solve the problem. And keeping that in mind, so we know that embeddings is a crucial part. Let's suppose you are trying to build a RAG application. In my generative AI class, I'm already teaching RAG. Right. Yesterday even I talked about that. Today also I'm going to talk about the application. So without this, you can't build RAG, first of all, right? Let's suppose if you're trying to go and train your models from the scratch, a best one. Without this, you won't be able to do it. Means without converting some data into its numerical representation, you can't do it, right? So I need a best one. I need the better one so that I will be able to create a better relevant data. And then I will be able to send those data into the models. Now this is where, and again, so if I'll talk about a word to vector, so it never takes care of like a positional encoding even. Right? Obviously, yeah, with the help of SkipGram and then with the help of CBOW, so it is trying to do the overlap with the help of Windows. But the problem is that it is never, or like so far, what we are talking about is, so it is not able to take care of the positional encoding, that which one will come, which one will come before, which one will come after, what is the significance of this before and then after. So again, there is a problem, a very, very huge problem we had with respect to a word to vector, which is our best of best so far that we have discussed, right? I'm not even talking about TF-IDF, or I'm not even talking about like a bag of word, because that is not even a part of race now, basically, right? That was the initial approach that we have discussed. So we can try to use basically this embedding models, and then we can get these things done. How we can use it? Let me show you that part as well, because in my upcoming classes, I'm going to use that. So we have given you a code sample, guys, over here. So let me just copy and paste this code sample. And yeah, so here I just have to replace this with my own API key. So you can go to here and then you can copy and paste this code. Replace with your own API key. So authentication, my API key I'm going to copy. So I'm just going to replace it with my own API key. Yeah. And then I can try to parse the sentence. As you can see, the food was delicious and the service was excellent. This was the sentence which has been parsed. I can try to pass my own sentence over here, right, and execute it. No module called as a request. Okay, I'll install the request module. Pip install request. Done. Okay, execute. And then call this generate embeddings. So yeah, I'm able to generate the embeddings, as you can see, right? I'm able to generate the embeddings of what? Of size 1536. It is returning me embeddings. Embeddings for what? Embeddings for the food was delicious and the service was excellent. Maybe I can try to parameterize it. So I can try to parameterize it as a text. So whatever text which I'm going to pass, text I'm going to pass, text I'm going to pass, this function should work for that. So here I can try to pass my text that my name is Dhanshu Kumar, I'm a data scientist. Now, as you can see, it is able to convert and it is able to return my embeddings, right? Return my embeddings of what? 1536 dimension. And that too, I'm trying to use an OpenAI model which understands a positional encoding, which understands a direct encoding, everything it understands. And it is able to give me the complete vector for this complete sentence, I would say. Is it making sense to all of us, guys? Yeah. Now this is going to be the best one, a long one, the best one. I can try to use it for RAG. I can try to use it for my model training. So I can keep on passing my data one by one, one by one, one by one. For example, maybe I have a data, right? I can try to write a comprehension over here so that for all the data, I have a data for I in data, and then like print generate embeddings for all the data one by one, one by one. See, so it is generating embeddings for all the data one by one, one by one. Yeah. let me remove this print from here. So it is trying to print only 5. Print embeddings, simple. Yeah. So now you will be able to see that for all this data, it is printing basically the embeddings. Yeah, keyword error data 1, 2, 3, 4, 5, 6. Only for 6 it is giving me this one. It is crashing after giving me 6. So 4, 5, 6. Hmm. Okay, somewhere I have like used print 2 times. Print embeddings is here. Do we have somewhere else print operation? Okay, so one is a return, one is a print. So twice it is trying to print. Okay, so anyhow it is trying to return, right? Remove the print part. Yeah. Now it's like see that I had seven data, right? So for all the data, so it is able to do the embeddings, beautiful embeddings. I am able to get it, and everything I am able to get it from my APIs, from my Euri embedding APIs. Now this is something, yeah. So we had 7 records, 1, 2, 3, 4, 5, 6, 7. So for all 7 records, I am able to get the embeddings. Every embedding size, if you are going to check, so it is going to be 1536 length, a constant length, right? 1536. Now you can try to pass this data in any places that you want, and then you will be able to train the model. You will be able to store this entire vector, right? You can try to store this entire vector into a vector database, for example, FAISS, or maybe into a ChromaDB, maybe into a Pinecone, maybe into a Bayviet, maybe into a MongoDB vector object. So you can try to store all of this data anywhere you want. You can try to build your RAG application. You can try to build a agentic AI based application, or maybe like a MCP based application, or anything that you want in your generative AI, right? Everything you will be able to do it with ease of use. So this is basically this is the advantage that you will be able to get with the latest cutting edge embeddings. Now this is basically based on the same transformer architecture that we have discussed. So here the neural network which has been used was a transformer based architecture, and the data set is a world data set. It's by OpenAI, by the way, right? So the OpenAI is not the only one who have done that. There are many other vendors, but yeah, I love this one a lot because dimension is very, very high. We are going to release other model as well, but yeah, this is the best. Even though this is going to be available, but I can say this is the best in terms of understanding the data. So now, question for me, guys? Any question? Sir, please update embedding in SDK. Yeah, I'll update it. As of now, code is given to you, but yeah, in SDK, I'll try to update it for embedding. So I have not pushed the SDK. I was not able to get a time since a long time because of recordings and a lot of stuff. But yeah, I'll just push into the SDK as well. It will not take much time for me, but yeah, I just have to work on that. So we have if you'll go and check, so we have released the SDK as well. So where you will be able to find out chat completion is an easy way. Basically, even you can try to install Euri AI in your local. For example, if I have to install Euri AI, I can just do like here pip install install Euri AI. Yeah, so it is going to install Euri AI. If you are going to write Euri AI hyphen model, okay, models basically Euri AI hyphen models. Here I can try to pip install install Euri AI. Oh, LangChain. It is expecting here. It should. Yeah, so here you will be able to find out all the Euri AI model detail till my last push, OpenAI, Gmail, like Google, Meta, and which model is good for what, everything detail you will be able to find out. And everything we have mentioned inside this like documentation, SDK documentation. And even we have released this LLMs for a Lang chain. So yesterday when I was talking about Lang chain, so I have used this one itself. It was very easy. Just call this and then put the API key and then like change the model name. And just like this code, this piece of one line is going to solve a lot of problem for me. So yeah, we have released a Python SDK, Node.js SDK for like a real-time search and real-time search and this one. Even for embeddings, code example is available. But yeah, soon we are going to release the SDK so that it will be very very easy. Just by doing a pip install, you can use it. Which should be the most perfect vector size according to your opinion, excluding any different model embeddings? I mean, like there is no ideal vector size, I would say, like the perfect one in general, but depends upon the task. But yeah, so as Euri has given you the response, 100 to like 300 dimension in general is the best one. But again, it depends upon the task that you're going to solve. So I can't give the exact number over here. Okay, so this is it, guys, and yes, so today we are able to cover this particular part. Word2Vector Glove is again one of the neural network based, but this one. Then in next class, so what we are going to do is, so we are going to see the practical implementation of RNN, LSTM, GRU, and obviously a transformer, a GPT based, BERT based, or T5 based, all of these transformer implementation back to back we are going to see. And we are going to build our own model because now we are able to convert our data into its numerical representation, which is the very first and foremost requirement for any one of us. And once this is fine, then we can go ahead with the next step where we can try to use encoder based model, decoder based model, or encoder decoder both based model. And then we can try to do the training, which I'm going to do in my next Saturday class. A lot of things we are going to do, a lot of training we will be doing in next Saturday class. So with that, thank you so much everyone. Take care. And yeah, so let me share this today's material. Copy path. So hope guys you are able to learn something. Are Globe and fastest embedding outdated compared to the OpenAI Amazon? Yeah, it's completely outdated. It's completely means completely outdated as per the current like a situation. 2 year back, obviously like Globe or 2Vector, all those models are very much like stable and very much useful. Not 2 years back, I think even before that, because 2 years back, what I remember is like we had a bot based model, embedding models, which was already in a place in a market. So yeah, before 2-3 year, these things was like a relevant, but not now. But again, like I said, so without learning ABCD, you can't go and like start learning how to form the sentence or vocabulary. So these are the like the things that I have discussed, TF-IDF and Word2Vec and all those things. It's basically an ABCD, which is helping you out to understand the problems and how we are trying to progress, and then what is the latest and the best one available to us. Okay, so with that, guys, thank you so much. See you again in my next class, Saturday class, obviously. And yeah, so in your dashboard, so I'll try to update yesterday's video by evening. I'll get time because I have another class right after your class. So I'll try to update your video for yesterday and even for like today. Material I have already updated. Yeah. And anyhow, we are connected over the group. Plus, we have launched not just 1 or 2 classes. As of now, we have launched a series of lot of classes now. Right. You can go and check. And again, structure wise, we have prepared the best of best structure in terms of projects and the books. This book issue is also fixed. We are trying to bring like a flip book feature for all of you. And soon you will be able to see a lot of handbooks over here. So yeah, spread the news, maybe talk about it over a social media so that, we all can get some sort of advantage. Plus, let me know about the feedback, how your classes are going on, what sort of an improvement that we are supposed to make. Maybe in your like group itself, we can initiate that discussion. So we'll try to implement those things. So with that, guys, thank you so much. See you again next week, Saturday. Thanks everyone. Take care.